definition
I don't have a paper.
of a definite integral. It was yesterday's.
It's a paper from yesterday, bud.
Well, let me find that.
Says
Great
that
St.
the
Anthony.
integral from a to b of some function f of x dx, where f is lowercase f, is equal to capital F of x integrated from b to a.
I don't like that there should be a flat line.
Which is equal to capital F of b minus capital F of a. So this is a definite integral because it has a value at its upper and lower bound, meaning that there is a number here and a number there. An indefinite integral would not have values in a and b. So definite has numbers at a and b. The relationship between f of x and capital F of x is that the derivative of capital F of x is equal to lowercase f of x. The derivative of capital F of x is equal
Derivative of
to
the integral.
lowercase f of x.
Are we gonna have to take derivatives of integrals?
Yes,
Why? It's just the original equation.
that's the fundamental theorem of calculus I was just referencing.
We don't know the fundamentals of calculus.
Well, what if the upper bound is a function? So the derivative of a function.
Oh, hell no.
Not integrating it then.
Oh, no. That ain't happening.
So that's what we get to.
No. The upper bound is gonna be a solid whole 3.
When are we taking a test or quiz on this?
Please, we
I
just
don't know.
started.
How do we find an antiderivative?
We're already through 3 parts of this.
Please, don't give her any ideas.
We haven't even gone through one notebook practice.
If x to the n is your function,
Well,
then
this stuff
x
is
to the n plus 1.
No, it's not physics, it's calculus. Stop talking.
An antiderivative using the
Right.
power rule for integrals
Is the opposite. So when you took the derivative, if it was x squared, you took a power away, so it became x to the 2 minus 1, and you multiplied by the original power. For integrating, it is the reverse of that. You take the original, so in this case, if it was 2x, you add 1 to your power and divide by the new power.
So if it was x squared, it would be
Sure, you want to do it?
1/3 x cubed.
So if we integrate x squared dx, exactly. You add 1 to the power, so x squared becomes x cubed. You divide by the new power.
This might be my thing.
Shut up. If I hear that one more time, you go for me.
Just messing with you.
So the integral from 1 to 2, if it has bounds that are numbers, our answer is also going to be a
Number.
number.
If it's bound, doesn't have bounds, your answer is going to be a number plus c.
Function.
Does the c stand for quarter?
Not a number plus c.
Chord block.
3 plus quarter long?
All right. So 2x. Antiderivative says you add 1 to the power, so 2x squared, divide by the new power, so you get 2x squared
Over 2.
over 2. Since this has bounds, you write the bounds at the end to tell you you're evaluating from 2 to 1. Simplify the 2 over 2. So what we're doing is evaluating x squared from 2 to 1. It is the top minus the bottom. So basically what we are doing is finding the area under the curve 2x. By anti-deriving, you're finding the original function. So you're taking the function value at 2 and the function value at 1. So you're integrating and finding all of that and then subtracting away what we don't need. That's what an antiderivative or integral does.
So our answer would be just x squared.
Our answer is going to be a number. So
you have
it's
to plug in
2
minus 1.
squared minus 1 squared.
The upper bound minus the lower bound. But
Upper minus lower. So 2 squared is 4. 1 squared is 1. 4 minus 1 is 3. The integral of 2x dx evaluated from 1 to 2 is 3. This is my capital F of x, or what we call the antiderivative of 2x. So now you think of it as multiple parts. The antiderivative of 3x to the 5th. So it becomes 3x 6 over 6 minus 1. So you get an x back, because it becomes x to the 1 over 1. From 0 to negative 1.
I'm confused on that part, then minus x.
the derivative of x is 1, so the reverse of that, the integral of 1 is x.
You got it. Plugging in your bounds, 1/2 times 0 to the 6th minus 1 times 0 minus 1/2 negative 1 to the 6th minus 1 times negative 1. So that zeroes out. Anything to a power that is even is positive. So this is 1/2. A negative times a negative is a positive. So you get 1/2 plus 1. So the final answer is negative
3/2.
3/2.
How is it negative 3/2?
The whole operation's negative, not just what's going on inside.
How do you know that?
They're always subtracted.
Top minus bottom.
Upper minus lower.
So that's why I bracketed the 1/2 and that 1, so that you knew that negative distributed to the final summation. Let's look at another one. Bless you. Okay. R over 2 minus 5. So R over 2 becomes R squared. The 2's don't cancel, they become a multiply, so they become 4. Minus 5r. All constants become linear, just like the derivative of something linear becomes a constant. Evaluated from 3 to 1. So we have 3 squared, which is 9, over 4, minus 15. Minus 1 squared, which is 1, so you get 1/4 minus 5.
Well, that sucks.
How does it? Because what's 9/4 minus 1/4?
Oh, you can just do it like that.
I mean, technically, you can
Addition is
distribute
negative.
it.
But it's subtraction.
So it's 9/4 minus 1/4,
Which is
and then negative 15 plus 5. Exactly. So 9/4 minus 1/4 is 8/4. 8/4 is 2. So you have 2 minus 10, or negative 8.
okay.
Oh, it's still snowing.
Number 5, think of that as 1 over x squared becoming x to the negative 2. So this is the integral from 1 to 2 of x to the negative 2 dx. So the power rule still applies. You add 1 to the power and divide by your new power. So that becomes x to the negative 1, because if you add 1 to negative 2, it's negative 1.
Our numbers don't line.
And then it's over negative 1. Oh, really?
No, this is number 4 for us.
It's alright. It's the same thing, it's just a different number.
I must have deleted a number 3 because I go 1, 2, and then 4, 5, 6. That's all.
So you get negative 1 over x evaluated from 2 to 1. So you get negative 1 over 2 minus negative 1 over 1. So that minus and minus turns back to a positive. So you have negative 1 half plus 1, which gives
Positive 1.
perfect.
Why is it plus 1?
Because this is negative 1. So if you plug in a 1, you get negative 1 over 1. But then again, the formula is f of b minus f of a. So the minus and minus turns to a positive. How about number 5?
That's your next one, right?
Yes.
Alright, so again, apply your rule. You have the integral from 1 to 5 of x to the negative 1 dx. So negative 1 plus 1 is
0.
divided by 0.
X to the 0 is 1.
So it's a constant.
It's 1 over
You can't
0.
divide by 0.
The answer is actually the natural log.
It is. Because the natural log's derivative is 1 over x.
That's one of the ones you just have to know.
Yes, so I kind of set you up to remember that. Did you Google it? Or did you know that?
When you
We
did
did
the
it in physics.
problem,
Oh, when I did the physics problem with you.
yeah.
Yeah,
Because
my own little trick away.
we didn't know why the hell 1 over x somehow answered with natural log.
Yes. So the integration of 1 over x becomes the natural log of x. It is an absolute value. So, because the natural log does not exist in the negative hemisphere. So, it's a natural log. Evaluated from 5 to 1. So this is the natural log of 5 minus the natural log of 1.
So the natural log of 5.
Exactly. So natural log of 1 is 0.
Corey, in your head calculator, go.
Ew, I don't know how to do a natural log.
7.3.
Someone check that.
I don't know.
You can say like 13.4. It's just gotta be.
Alright, pick a random number. I think that's too high.
Yeah, I think the
natural log's like
1 point something.
What did you say, Deja?
I'm gonna I'm changing it to 6.4.
I'll say 5.2. Alright.
Blaze, say
Blaze.
6.9.
That's
funny
what I
that
was
way.
gonna say.
What did we all guess?
No.
I-
That's
no.
the answer.
I'm gonna guess somewhere around like 7.1.
Alright, I'm going little. I'm going with like 2.2.
I'm going 4.8.
4.269.
You can't change
1.6.
I was close.
I was the closest.
1.6. That's what I said.
Yeah, I think I said that actually.
Alright, next.
Excuse me.
Disgusting.
I agree.
Alright, so any x in the denominator without an x up top to cancel or without being raised to a power is a natural log.
So we just don't do this one.
Yes, you do. Because the derivative of natural log is 1 over u. So the inverse of that would be the natural log of u.
So it's a natural log of 2.
X plus 2.
X plus 2.
See, give up.
Alright, take your guesses. My answer is going to be, it's not, I was going to add 2 to 1.6.
It's not gonna work.
So you get the natural log of x plus 2 evaluated from 5 to 1. So that becomes the natural log of 7 minus the natural log of 3. So it's the natural log of 7/3.
Oh, hold on. That's like a little over 2. Yeah, it's 0.6.
0.8.
I was gonna say 0.8.
0.69.
I'm gonna say 0.9.
0.3.
0.5.
0.847.
What did I say?
I said 0.69. That's
I
the
think
closest.
I would know. I said 0.8.
You went over. No, this is like
Okay,
I
so
said
we're
0.8,
like-
so I would be closest.
Yeah.
over. I win.
That's 0.8.
It's 0.84.
Mine is funnier.
So 4 is closer to 0.8 than anything else. That's right. That's right. Let's just win like that.
All right. Number 8. The integral from 0 to 1. Now again, we have x squared plus 1 and 2x.
So this is still going to be a natural log.
Because the x squared plus 1 is our u. The derivative of x squared is 2x. So it's 1 over u with u prime up top. So you just have to start to pick up or look for that pattern. Ow.
So did anyone else hear that?
That was my neck. I literally just only listen. I just thought it sounded loud in my own head.
No, I heard it.
I'm all the way over here.
So you get the natural log of 2 minus the natural log of 1, which again becomes the natural log of 2. And I just kind of like put a little summary down there, like, remember a rule, subtraction becomes division, and that's why the natural log of 1 becomes canceled out, because even if you divide it, it becomes 2 over 1, which is 2.
So why did we lose the 2x in the beginning?
Because
That's
the
just the
derivative,
derivative.
so if you think about a natural log's derivative, it's 1 over
Prime
u
over u.
times, exactly, u prime. So the u prime is the 2x, the u is the x squared plus 1.
So the numerator doesn't matter.
No. Because the antiderivative,
If it's anything over x, it's going to end up just being a natural log.
no. Because 1 over x squared is fine.
You
It's-
needed the 2x to show you that it would have canceled out.
It's,
Oh, because the derivative of x squared is 2x.
yes.
So if the numerator is the derivative of the denominator, then it's a natural log. That's
Killer numbers are like 68
Yeah,
squared.
So you have to take the
till I get
derivative
a
of a
del-
square root chain rule in the denominator to find out if the numerator.
Till I get a
Then you
delta-
can start integrating.
Until I get a delta map and it's like 5,408x squared.
No calculator.
No calculator.
X
So,
squared,
like-
just multiply by 2.
All right, this is an example that you don't like, right? Because
No.
the derivative,
doesn't
the
matter.
denominator of the derivative is 1. But there's that constant 2.
So it's not ln. So
It is ln,
so you
but you
pull
have
the
to
2 out
pull the
front.
2 because it's a constant out in front. And now it becomes an ln rule.
See, I wouldn't have thought to do that. I would have just started doing
Yeah,
other
see.
stuff.
Why do you think we do examples?
Well, because I'm sure there's another way to solve this, other than that. There's always more than one way.
Not always.
This is the way.
There's only one way to solve 4 plus 2.
Okay, that's a terrible example
Yeah.
because it's 2
2
plus
plus
4.
There's only one way to solve. No, it isn't.
Yeah?
Yeah, 4 minus 2. There's only
That
one way
is-
to solve
that
4
is
minus 2.
3 minus 1.
Does it not
But
He's saying same numbers.
I didn't say that.
But it's implied.
No, it wasn't.
Only smart people would know that it's implied. It is implied.
Well, I don't understand calculus.
All right, this
We missed the fundamental theorem.
ln of h
minus
minus ln4, which equals ln2.
ln4
Yeah, 1 plus 3.
negative 1.
2.
Minus 1 plus 3.
See, he was messing with me and got him all screwed up.
When did it become a negative down there?
At the beginning.
When the problem was written.
See, I was too busy thinking about 4 minus 2.
I know. It's all scrambled.
Sorry. I like to see how you change colors.
Oh. It's per color,
There's
it's
no
per
rhyme or
problem.
Yeah, but
Got it.
Just to like
It's not on
make it
purpose.
look
It's actually an
better.
accident. Where did 64 come from?
The problem.
That's-
Take the 2 in front and it's the square.
Exactly. The 2 in front
Oh,
becomes
yeah.
the power. So I was trying to show you, like, there are sometimes multiple streams. So this one, you have like 2 paths you could take to get you to the same final.
So the answer to ln of 16.
The answer is the ln of 16.
See, why couldn't I just do ln 8 over 2 times 2? So that doesn't work.
That would be ln of 8 over 2 and then 4 squared.
Squared, yeah, that's what I said. Essentially.
Alright.
All right, guesses?
Oh, well, what is it? Ln of 16?
3 point,
6.1.
4.2.
6.1. Think about it. I'm right. It's 6.1.
So you say 6.1, you said 4 point?
I'll say 4.1.
I'm gonna say
4.1.
3.87.
Is it 16?
No.
I'm gonna go 5, 2.
Because if the ln of 5 was 1.8,
1.6.
1.6, multiply that by 2, add on another 1,
Actually, I'll say,
6.1.
1.6 times
I'm
2?
gonna say 5, 2.
I'm going to say my
3.2.
4.1.
All right, I'll go below you. I'll go 3.2.
I said 3.87.
It's 2.7. That was
How? That
tiny.
doesn't make sense.
Tiny. I don't know the natural logs function.
Neither do I.
Now, they usually sneak one of these on you every year. The Arcsin or the Arctan are the only 2 you need to know. The Arcsin and the Arctan. That is where you have the x squared in the bottom, but no x up top. So the natural log needs the derivative up top, right? So if there's an x squared on the bottom, you're looking for that u prime over u squared plus 1. Or u prime over the square root. I only put these on there because sometimes the book sneaks them in. And, like, I assign you the problems and they look normal and they look good. And that's like, oh, crud. They were not normal. They were not good.
I do not like this. I don't
It's just like that they were not normal. They were not good.
Because they aren't. And, like, they sneak them in. Like, they're stealthy about it. And I'm always like, why? Why'd you put that in there? I was not ready for that.
That's what I say too. Like, I'm not talking about the book. I'm talking about the problems you assigned us.
Hey,
Why'd you put that in there?
She said.
Oh, that's not funny.
Oh, yeah, it is.
I mean, that was too good not
Nope.
to acknowledge.
I think I'm giving you a worksheet. I don't like the textbook problems.
Okay.
That's a new book. I don't like them.
I didn't think about that one, Susan. That was a good.
That was